Okay, question 4. We've looked at this in a slightly different situation. When I did it in class, we had got 2 magnets, north and south, and we had a wire which was kind of through the 2 magnets. And I got the wire and I moved it. And I moved the wire upwards, and that meant that a current flowed. And because this is generating electricity, we use the right-hand rule. And remember what that means. North to south is that way. The wire is moving upwards, so the current would flow in this direction. That was what we did in lessons. Now this is slightly different. We've got 2 wires and a wire on wheels which will move through. So this wire is moving through in that direction. Now we know that there is a magnetic field, and over here we did the magnetic field was like from north to south. This time we've got the magnetic field going like this, north to south. So when this passes in to the magnetic field, it's cutting flux. So describe what is seen happening to the pointer on this sensitive center zero voltmeter. What you will see is that the pointer will move in one direction. Because I'm moving that through in one direction. Now it's actually 2 marks, so we might want to think about what's going to happen after the thing has passed through. The pointer will move in one direction. Once it's come out, it will, once this has moved to over here, it will go back to 0 and then return to 0. Explain why this happens. Well, 3 marks. We have said already, it's this law. This gives us the direction of the current when a wire is moved. But to answer the question, we actually need to think about the fact that this is going to be cutting through those green lines. The axle on the wheels cuts through the magnetic flux between the magnets. So it cuts through. This induces a voltage on the axle. Okay, that induces, that's a key word, that we have induced a voltage. And also cutting through the magnetic flux is important. Cutting through the magnetic flux induces a voltage. This is called Faraday's law. Okay. The metal wheels are now rolled back, so they're going back the other way. Describe what happens to the millivoltmeter pointer. The pointer moves in the opposite direction. Now we could work out the direction actually, couldn't we? Because it's the right-hand rule. North to south, and then the movement is the thumb. So I make that look north to south like that. The movement is this way. So actually the current will flow in this direction. So actually it'll go back like that. So you would get the current flowing in that way when it moves this way, and the opposite when it moves the other way. Okay.